Welcome back. Problem number 2, the roast turkey problem. I already did some of the work because it's pretty redundant. I'm going to go ahead and pause or ask you to pause the video if you want to go ahead and take a look at this part of it where we again start with Newton's law of cooling. We have a surrounding temperature of 75. We separate the variables to solve for y. Again, what this says is the rate of change of the temperature, or the rate at which the temperature is changing, is proportional to the difference between the current temperature and the surrounding temperature. And this is a roast turkey. Okay, so anyway, go ahead and again pause the video so you can make sure you know how to get down to this point here. And I'm going to move this over. Excuse me. Part A, it says that if the temperature of the turkey is 150 after half an hour, so I convert that to just minutes because I'm noticing here I've got 45 minutes, so I'm just going to make everything in terms of minutes and pause the video until you understand how we get K. I've already stored that on my calculator, and so let's go ahead and proceed. We're being asked, what is the temperature after 45 minutes? So what is the temperature after 45 minutes? What that's really asking us is find y of 45. Well, we already know y of t. Y of t is, where is it? 75 plus 110 e to the k t. Therefore, y of 45, for the temperature at the 45-minute mark, is 75 plus 110 e to the 45 k. And I'm going to go ahead and plug that in. I'm going to do it a different way this time. 75 plus 110 e to the 45 k. That's actually a lot faster than plugging into the y1. But if you did need to use it again, plugging into the y1 or letting y1 equal that function is a good way to go. So we get 136.929. And what is that? So that is 136.929. And I always, at this point, instead of just diving right into the units of measure, I look at the question, what is it asking? What is the temperature after 45 minutes? And well, that would be degrees. And the last problem we had Celsius, but this one we have Fahrenheit. Now asking myself, though, is that a reasonable answer? It's a super important question to ask. It cooled down from 185 to 150 in a half an hour. Okay, so it dropped 35 degrees. Now, this is not linear, so it's not necessarily just going to drop another, well, that's in 30 minutes, so 15 more minutes doesn't mean it's going to be half of that. So obviously what we got here. But it is reasonable to expect it to be about, so this is a difference of 35, so half of that would be, so 15 more minutes, so half of that would be 17 and a half, and so we expect it to drop about 17 or so from 150, and so 136.929 is in the ballpark, and so we can feel pretty good about that. Okay, and let's go ahead. Now, where's my red? I like to box things in red. I can't tell if that's red or orange. Kind of dark in here. Anyway, there we go. So the next question is, when will the turkey have cooled to 100 degrees Fahrenheit? So when, we're finding time, so we want the t time, when y of t equals 100 degrees Fahrenheit. Okay, so we let y of t equal 100, and we still have the 75 plus the 110 e to the k times t. Subtracting 75 from both sides, this is 25, and then dividing by 110, and taking the log of both sides and dividing by k, that's going to give us a time. So that's actually the quickest I've ever done that when I've been explaining one of these problems, but we've been doing these so much, I just wanted to show you the way I would do the problem. So I'm just visualizing myself subtracting 75, dividing by 110, taking the log of both sides, and then dividing by what's still attached to that t, and then anyway we get that. So let's go ahead and type that in. Log of 25 divided by 110. We're going to divide that by, I always store things in my alpha A. So that's 116.055. Okay, so t is about 116.055 when. Okay, so when, that would be at the 116 minute mark. Okay, and there we go. There you go. I'm going to sign off for tonight with the Newton's Law of Cooling. Have a great day.